sorry about this. The final exam is going to be on Blackboard, just like the midterm was, and just like the test that I gave you that has to be completed by Monday, the December 13th. Some of you have already done it. Remember, for the final exam, there will be a total of 30 questions. You will have a total of 2 hours to complete it, 120 minutes. Once you start it, you must do it in one session. You can't stop it and then go away and come back to it. But again, make sure you do the practice final. The practice final actually has 40 questions, just a little bit more questions so that you can have.
Bottom right corner of Kitty's workstation. Remember the battery icon is? You still up arrow that's right there. Click on that. I just want to see what Kitty's got running in the background.
The next two sessions we have today and Thursday is basically going to be reviewed. Today, for specifically, I'm reviewing the exponential and logarithmic type of questions. I also will review the trigonometry type questions, so that, and then if we have some more time than that, then I'll go back. I'll sort of start going back. What I will plan to do is, if you have any questions on the material from before the midterm, questions that were on the midterm and those type of questions, if you still have any questions, please make sure to bring them up and I will review those on Thursday. So today we're doing basically review of the examples of the material that we learned after the midterm. Again, the final exam is a week from today. You have a total of 2 hours to do 30 questions. You must have all homeworks and tests completed. If you're still missing any work, it must be completed by the end of next week. I will be submitting grades by either Friday or Sunday of the week following the 14th. In other words, sometime by the 20th, I want to have my marks in. So I have to, once I submit your mark, if I see that you're missing material, it's going to count as you're not going to get complete credit. Let's say there's 10 points for homework. If you've only done half the homeworks, and you'll only get 5 of those 10 points. That, again, 35% of your grade is the final exam. 25% of your grade was the midterm. That takes care of 60%. The other 40% consists of homeworks and tests that I gave. And there have been a total of, so far, 3 tests on Delta Math. And you're now going to be having your second test on Blackboard. You should have completed your tests on Delta Math. Again, if you need additional time, you just have to email me and I will extend the time for you. But I will only do it if I get a specific request by email. Okay, let's see. And I see that Shauna has given us an answer. So let's work on this together. The first thing it says is we just want to expand this into individual logs. We have the log base 2 of the cube root of 8 divided by b squared and c cubed. Now, if you recall what I said, when we're dealing with this topic of logarithms, we do not use radicals. We use only exponents. So when I see something like the cube root of 8, I rewrite this as a to the 1/3 power. Every radical can be written as a fractional exponent. So this is just using the information we had learned when we were talking about exponents. After I have everything expressed either as multiplication, division, or exponents, I can then go ahead and expand. So I like to do it in 2 steps. The first thing I do is I look for any multiplications and divisions. When I'm talking about a fraction, anything that's in the numerator is going to be positive, it's going to be added. Anything in the denominator is going to be negative, because in logs, just as in exponents, when we're multiplying, we add exponents, and when we're dividing, we subtract exponents. The logs are exponents. So this is going to come out to be the log base 2 of a to the 1/3 minus, we're dividing by this, so when it comes to the logs, we're subtracting the log base 2 of b squared, and also minus the log base 2 of c to the 3rd. Even though we are multiplying the b squared and the c to the 3rd by each other, both of these are, the a to the 1/3 is being divided by them. They're both in the denominator, so they both have to be negative. Now what I can do is I now look at for exponents, because when we're dealing with logs, the exponents become the coefficients. So here the exponent of 1/3 is going to be 1/3 log base 2 of a. There's an exponent of 2, so this becomes minus 2 log base 2 of b. And here we have an exponent of 3, so that becomes minus 3 log base 2 of c. And these are now expanded in terms of individual logs. Again, where there's pluses, it'll mean that something is in the numerator of the fraction. Where there's minuses, it's in the denominator. And any number that's in front came about because the exponent became the coefficient. Because when you're dealing with logs, as you're dealing with exponents, when you have 2 exponents on a number, and the log a is 1 exponent and the 1/3 is another exponent, what you're doing is you're multiplying those 2 exponents. So this is just a matter of using what we call the properties of log. I'm not rewriting the properties of logs, but this is how we expand it. And that was oh, you thought that was a 2 instead of a 3? Fine. That was just, I really guess I should write it. This is a 3. If you're doing this, if you're looking at this on a small screen, it's hard to see. I agree. That was excellent, Shauna. Okay, now let's look at the second thing. Here we're given the log base 4 of x plus 1 plus the log base 4 of x minus 5 equals 2. And we're asked to solve this logarithmic equation. Now, in general, when we want to solve something that has to do with logs, we usually like to go back from the log format to the exponential format. Except we can only do that when we have a single log on a side. So the first thing we have to do is just the opposite of what we did here. Here we took one jumbled up bunch of things and made it into individual logs. Here we have individual logs. We want to contract it back to a single log. And here I look at between the two logs, there's this plus. And again, I remember when I'm adding logs, it means I'm really multiplying the numbers. When I'm subtracting the logs, I'm dividing. When I'm multiplying, I'm adding. So I can rewrite this as log base 4 of x plus 1 times x minus 5. I'm taking this plus, I'm converting it back to what it was originally. Since the logs are being added, it must have been the numbers were being multiplied, and this is equal to our 2. And remember the basic rule about logs, that if, well, let me put this on the board over here because this is so important. If we have the log base b of a equaling c, that converts to the base b, the subscript, to the number on the other side of the equation, what the log is equal to. Remember, log really means exponent. So the exponent is equal to c. So this is b to the c exponent equals a. And I can do this even when I have an equation. Anytime I have the log of something equaling a number, I can convert it from the log format to the exponential format. Also remember, if no number is written over here, if no base is indicated, it means the base is 10. It's not that it was forgotten. If there's a subscript, that's your base. If there's no subscript, if it just says the word log, then your base is 10. Well, in this case, our base is 4. So we're taking the 4. The exponent is a number on the other side of the equation, so that's 4 to the 2 equals that whatever is written right next to the word log, which is the x plus 1 and the x minus 5. And we have to solve this equation. So first of all, 4 squared I know is 16. And x plus 1 times x minus 5, I'm going to use FOIL to multiply this out. So this is going to give me x squared. Outer is negative 5x. Inner is plus 1x. And last is minus 5. Which will give me, and I'm going to rewrite this so the x's are in the front and the number, I'm just going to switch the order here. So this is going to give me x squared. Now negative 5x and 1x give me negative 4x. And the 16 I'm going to bring to the other side to get it equal to 0. So that gives me minus 21 equals 0. I had to actually do the FOIL so I could combine everything, because when I have a quadratic equation and I want to solve that quadratic equation, I want to get it equal to 0. And now I'm going to factor this, and since my AC is negative 21, and my B is negative 4, I think you can see that the two numbers that we want to multiply are negative 7 and positive 3. We want to break this up into x squared minus 7x plus 3x minus 21, because that'll give us the negative 7x, and the plus 3x will give us our negative 4x. And This will give us x times x minus 7. And this will give me plus 3 times x minus 7. So this gives me x minus 7 and x plus 3 as the factors of the x squared minus 4x minus 24. Notice I had to multiply the two binomials, bring the numbers together so that I had it equal, because this was equal to 16, it was not equal to 0, and then refactor it. Now that gives me, I see that you might not be able to see that last bottom part. Let me do that. So going over here, we get x minus 7 equal to 0 as one answer. So that gives me x equals 7. And x plus 3 equals 0, which gives me x equals to negative 3. And you have to be very careful because you can only use positive numbers when you're dealing with logs. So when I pick the x to be 7, the 7 plus 1 is 8, so that's positive, that's good. The 7 minus 5 is 2, that's positive. So both of these numbers are positive. X equals 7 works. But when I have x equal to negative 3, this would give me a negative 3 plus 1, which is a negative 2. I don't have to go any further. I cannot take the log of a negative number. So x cannot equal negative 3, and the only correct answer is 7. Remember to check your answers to make sure, because I guarantee you that in a multiple choice question of this, one answer would be 7, one answer would be negative 3, one answer would be 7 and negative 3. And don't pick that answer. The negative 3 is not a correct answer. It is what's called an extraneous root, and we cannot use that answer. Okay, I see you got it also. Excellent. And so these are some questions from logs. Now I'm going to put another couple of questions on the board, and I'm going to give you time to do them so that I can take attendance. So I'm going to erase this. I'll leave this up. So let's say I gave you this question. I want you to solve this equation. Find the value of log base 2 of 8, number 1. And number 2, see if you can solve this. 4 to the 12 minus 2x equals 64. This is an exponential equation. So I'm giving you time to do these two questions while I take attendance. Jesus Antonio Jackson Avila. Hi, Jackson. Tiffany Basilio. Caleb Brantley. Tashana Caesar, I know you're here, Tashana. Dion Carter. Wensley Charlemagne. Tatiana Collins. Hi, good morning. Awa Diallo. Good morning. Ashay Douglas. Hi, Ashay. Eliana Estee. Emily Gomez. Anastasia Guerra. Zainabu Hamad. Ismail. Jaden.
Yeah.
Hi. Ashiana. Hi. Onijah John. Thomas John.
Yeah.
Hi. Paul LeBrun.
Here.
Hi, Paul.
Good morning.
Ashley Moorhead. Angelica. Tayon. Akeem Richards. Hi, Akeem. Craig Ricketts. Giovanni Rowe. Devin Lee.
Here.
Yeah, hi, good morning. And Najay Waddell. Yes, Tayon, I did say your name and I'm putting a register, okay. Don't forget that we do have, as per scheduled, the SI hours, the supplementary instruction hours with Damilola. If you have any questions, he definitely will help you with them. All right, I see that I'm getting some answers also from these questions, so let's take a look at them. Okay. And both, oh, Demalola mentioned that today there is tutoring at 12, like he put it on the chat for all of you to see, I guess. Thank you. Okay, and I see both people who entered answers got the same answer, so I'm going to assume that they're right, but let's do them together. First of all, we want to figure out the value of the log base 2 of 8. Now, usually you have it equal to something. It isn't equal to something, and we don't know what it's equal to, so we can just put it equal to any letter that we want. We know it's called X. And then we can change it from its log format to its exponential format. Remember, the base here is 2. The exponent is the number on the other side, which is the X. And that equals the number that's written right next to the word log, which in this case is 8. In other words, we really want to solve this exponential equation of 2 to the X is equal to 8. And I can figure that out by just multiplying 2 by itself several times. 2 times 2 gives me 4, and 4 times 2 gives me 8. So obviously the exponent that I would have to put onto the 2 to get to 8 would be 3. So in this case, my answer is 3. The number that the log base 2 of 8 is, it's equal to 3. So again, once you have the question written from the log format into the exponential format, it becomes easier to solve. Now let's look at this one. Already is an exponential form, and we want to solve this exponential equation. And what we try to do is get both sides of the equation written in terms of the same base. Now, obviously, this side is being written in base 4. So let's see if we can write the 64 as a number in base 4. Can we write 64 as 4 to some exponent? Well, you might remember 4 times 4 is 16, times 4 is 64. In other words, I could write this, I'm leaving the left side alone, but the 64 I'm writing as 4 to the 3rd power. And once the two bases are the same, then we can ignore the bases and just work with the exponents. The exponents have to be equal as well. The 12 minus 2x has to be equal to the 3. And this just becomes a regular algebraic equation to solve. So in order to solve it, the first thing I'm going to do is I'm going to bring this 12 to the other side. That'll leave me negative 2x equals 3 minus 12, which is negative 9. And then to get the x alone, I'm going to divide by negative 2. And of course, a negative over a negative is positive, so the answer is 9 over 2. And the best way to leave it is in that fractional form. Again, if you wanted to, you could put it in decimal form, but I would say on a multiple choice exam, the answers will probably be given as fractions. And that's how you would solve this exponential equation. What if I gave you an exponential equation that looks like this? Suppose I gave you 6 to the x equals 42. And I want to solve that equation. And if I try to do it the same way I did over here, I should, the base being used here is 6. See if I can get 42 written in base 6. Well, 6 times 6 is 36. And 36 times 6 is already 216. I never reach 42. I go right past it. The first number is 6 times 6 is 36. That's too little. The next number is 6 times 6 times 6, 6 to the third is 216, and it's too much. So the question is, what happens if we don't have the possibility of writing both sides in terms of the same base? So you might recall that I told you you could do this, and you could do it even with the other ones, but certainly when the two numbers can't be written in the same base, you can use logs. What you do is you put the word log in front of both bases, both numbers. So we're going to get log of 6 to the x equaling log of 42. Now, if you notice, I didn't write any base here. I didn't write any base because I want to use a log that is on my calculator, and that is the log base 10. And when I write just plain log without any base, it's understood to be base 10. Now, the reason I do that is because when I have logs, remember what we said, the exponent will work itself out to be the coefficient. In other words, we can rewrite this as x log 6 equaling log 42. And then to get the x alone, I'm going to divide both sides by the log of 6. And this is where my calculator comes in. In my calculator, I press the log button. I enter the 42. Usually it opens up a parentheses. I close the parentheses. I divide, and then I press my log button again. And again, it opens up that parentheses, and I put in the 6, and then I press equal. And when I do that, I'm going to get log 42, close parentheses, divide log 6, close parentheses, enter, and I get 2.0860. I'm going to write the whole thing I'm seeing on my calculator. And actually, it probably goes on further than that. It's an irrational number. It doesn't come out to be an exact number. Let's say they asked me to find, I didn't tell you, let's say they said find to the nearest 100. So the nearest 100th would be the two places after the decimal point, which would be after the 8. And the number after the 8 is a 6, which means I have to increase it. So this would become 2.09 as your answer for the exponent. Notice it doesn't come out to be an even number because we couldn't get this 42 in a base of 6. So but we can do it using our calculator. I'm trying to think if these are the type of examples you have to be able to change from logarithmic form to exponential form. You have to be able to solve exponential equations if you can get them in the same base, or if you can't. and you have to be able to solve logarithmic equations. But we've done a few of all of those. I think, unless somebody has a question, that pretty much takes us pretty much through what you have to know about logs. Obviously, there's a lot more that you can do with logarithms, but this was a pretty good review. It's a review of how to change from logarithmic form to exponential form, how to solve logarithmic equations, and how to solve exponential equations, and how to expand logs into individual logs. So if you have a complicated expression like we did at the beginning, we can expand it into its individual logs. Would you like to do one more like that? Let's do one more expansion, and then we'll go on and review some trigonometry. So let's see if you could expand this expression. Suppose I gave you log base 5 of x to the 4th over y times z to the 2nd. See if you can expand this in terms of its individual logs. You should be looking out for an email from me also. If you're missing any work, I will email you and let you know what you're missing. If you want, if you're, because any missing work is going to affect your final grade. Okay, let's do this one together. Again, we have log base 5, or x to the 4th over yz squared, and we want to expand this in terms of its individual logs. Remember, when we're expanding, any place we see multiplication, in other words, anything that's in the numerator that's being, those, you're going to add those logs. Anything that's being divided, you're going to subtract those logs. Again, anything that's in a denominator is considered being divided. So you're going to subtract those logs, and any exponents are going to become coefficients. Those are your basic rules of expanding logs. It's called log properties. We don't have to switch any radicals. We have no radicals in this expression, so we don't remember if anything is written in radical form, we first change it to exponential form. So here, the first thing I'm going to do is look for the multiplications and divisions, and I'm going to have the log base 5 of the x to the 4th. There's nothing being multiplied by it, but the next things are going to be subtracted because they're being divided. They're in the denominator. So there's going to be a log base 5 of y. And also we're going to subtract the log base 5 of z squared. Because both of these are in the denominator, they're both being subtracted. They're both considered being divisors. I then go back and I look for any exponents and put the exponents in front. So this 4 becomes the coefficient for log 5 of x. This doesn't have any exponents, so it just stays log base 5 of y. And here we have an exponent of 2, so that becomes minus 2 log base 5 of z. And that would be the expanded version of this log example. Okay. I think that pretty much takes care of the log examples. Let's try some review of trigonometry examples. The topic we had learned just previous to this, exponential and logarithms. Suppose I gave you an example like this. And I told you side A is 15 and side C is 21. And I want you to figure out what is side B. If it doesn't come out evenly, write it in simplest radical form. Okay, I'm giving you a few minutes to try that. Anybody have any answers yet? Okay, I think we can work on this together now. Obviously, this is a right triangle, and this is my vertex A, this is vertex B, this is vertex C. We usually put the C at the right angle. Now remember how we set it up. The lower cases are represent the sides. This is side A, because it's opposite the capital A. That we were told was 15. Side C, which is opposite the angle C, opposite the right angle, is over here, is 21. This is what we call the hypotenuse. And this is my side B, and that's what we're looking for. And of course, we remember when we have a right triangle, the famous Pythagorean theorem, a squared plus b squared equals c squared. So we will have 15 squared plus b squared equaling 21 squared. I'm going to erase this here. And I'm, of course, going to be using my calculator. Don't forget that you are allowed to use a scientific calculator, not a graphing calculator, but a regular scientific calculator. So we have 15 squared, which gives us 225. And the 21 squared, which is 441. And I'm gonna subtract the 225 from both sides, which will give me that my b squared is equal to 216. So that means that b is the square root of 216. Now, I asked it to be put in simplest radical form, which means not in decimal, but in radical form, but simplified. And Paul is, he wrote that.
Call from 1217-281-7292.
This is a correct answer, but it's not in simplest radical form because you can break up 216 into the square root of 36 and the square root of 6. So this becomes 6 radical 6, which is the answer in simplest radical form. Yes, Paul, that was correct. I have to tell you, some of your, not this graphing calculator, which I use, that doesn't do it, but some of the nice scientific calculators will simplify radicals for you. I think I don't know if the TI does, but there was a Casio that does it. Maybe the TI 30 does also, I'm not sure. But that's one of the things that you want to, it said simplest radical form, you'd have to break up the 216 into 36 and 6, which would give you as your final answer 6 radical 6. Okay, let's do a different problem now. What if I gave you this question? Suppose I give you a right triangle. And suppose I call this angle theta. Remember, we use the Greek letters for theta. And here's what the picture looks like. I have a 26 over here and a 10 here. And I would like you to figure out what is the cotangent of theta. Find the cotangent of theta from this diagram. I'll give you a few minutes to try that.
Do we have to simplify the answer?
What?
Do we have to simplify?
If you can, simplify it.
All right.
Okay, let's see if we can work on this together. Remember, the primary thing we want to remember about trigonometry is this mnemonic device, SOHCAHTOA, which tells us that the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. That's number one. And number two, to remember the three, those are the three primary trigonometric functions. The secondary ones, what we call the reciprocal trigonometric functions, for the opposite, is the cosecant, which is abbreviated CSC, which is the reciprocal of the sine, the secant, which is the reciprocal of the cosine, and the cotangent, which is the reciprocal of the tangent. So if we want to figure out what the cotangent is, we first want to figure out what the tangent is, and then we just flip it over, and that'll give us our cotangent. So let's see what we have here. To find the tangent, we'd have to do opposite is opposite, TOA, opposite over adjacent. Now, if I look at this, this is my opposite side. I wasn't given my opposite side. This is my adjacent side, and this is my hypotenuse, because the hypotenuse is the one that's opposite the right angle. So the first thing I have to do is to do my a squared plus b squared equals c squared to get the opposite side. So I'm going to do a squared plus 10 squared equals 26 squared. So we'll have a squared plus 100 equals 26 squared. Which is 676. And I'll bring this 100 to the other side, so that I'll get that a squared is 576. And when I do the square root of 576, it turns out that I get a is 24. It comes out to be a perfect whole number. In other words, this side turns out to be 24. 10, 24, 26 is what's called a Pythagorean triple, because a squared plus b squared equals c squared. Well, now that means that the tangent of theta is TOA opposite 24 over adjacent, which is 10. Which means that the cotangent of theta is the reciprocal of that, which is 10 over 24. And of course, we can reduce this by dividing top and bottom by 2, which gives us 5 over 12. And the correct answer is 5 over 12. And that would be the correct answer, 5 over 12. A couple of people did get that answer, great. We have a few minutes. Let's just review a couple of questions that have to do with the conic sections. Let's say I ask you to find, I'm giving you this equation, x squared plus y squared minus 4x plus 6y minus 12 equals 0. This is the equation of a circle. We know that's its equation of a circle because it has a plane x squared plus a y squared. Coefficient of the x squared is 1, the coefficient of the y squared is 1, and there's a plus in between them. This is a circle. I want you to find the center and radius of the circle. Give you a couple of minutes to do that. Okay, Awa has a answer. Let's see if he's correct. Well, okay, so if you recall what we said we would do, we would have to do the completing the square on both the x's and the y's. We put the x's together, so we have an x squared and a negative 4x, and we leave a space. We put the y's together, so we have a y squared and a 6y, And the number that doesn't have any X or Y, we bring to the other side of the equation. So we have a binomial here that has X's in it and a binomial here with Y's in it. And we want to make these into perfect square trinomials. We want to add a number, that's why it's called completing the square, that'll make this a trinomial that can be factored into a binomial square. And we do this by dividing this number in two. We divide the -4 by 2, we get -2. And we multiply it by itself. -2 times -2 is +4. And I add 4 to this to make this a perfect square trinomial. Now, if I add 4 on this side, I've got to add the 4 on this side as well. This then becomes the x minus 2 squared. If you did x minus 2 times x minus 2, that's what you get. You get x squared minus 4x plus 4. Now we do the same thing with the y's. We take half of the number in front of the y, so that's half of 6 is 3. And we multiply it by itself, 3 times 3, and we add 9. Of course, I add 9 over here means adding 9 over here. This then becomes y plus 3 squared. Notice this was a -2 because this was a -4. This is a +3 because it's half of this is +6. And of course, on the other side, 12 plus 4 plus 9 adds up to 25. We have now put this equation in what we call the standard form. And the center of the circle is the opposite of these two numbers. It's +2 and common -3 for the center. And the radius is the square root of this number, which is 5. So our center is 2, -3, our radius is 5. And that's what I see. I'll got that 2, -3, and 5 as a radius. Excellent. You definitely will have some kind of question like this on the final. Just let's do one more question and then we'll finish up on Thursday. And that, let's talk about a parabola. What is the vertex of this parabola? Find the vertex of the parabola. Y equals x squared plus 4x plus 5. Okay, I think we can work on this together now. Remember the formula, and don't forget all these formulas. You can find on this study guide that I put out for you on, it's posted on Blackboard. It's called the Study Guide for Math 136. And it has all the different formulas that you will need. And it's a review of all the different topics. It's a very good review for you. The way we find the vertex is we use the formula x equals negative b over 2a to find the x value of the vertex. Now the a in this case, there's no number in front of the x squared, so that would be a 1. The b is the number that's in front of the x, which is 4. The c, which we really don't need in this case, is 5. So in order to find the x value of the vertex, we're going to do -4, and that's negative b, over 2 times 1. So -4 over 2 gives me -2. So my vertex is going to be -2, but that's not enough. I need to know what the y value is as well. And the way I find the y value, because a vertex is a point and you need both an x and a y, you put the -2 into the original equation. So you're going to get y equals -2 squared plus 4 times -2 plus 5. So -2 squared is +4. 8 times -2 is -8 plus 5. So we have 4 minus 8 is -4 plus 5 gives me 1. So my vertex is the point -2, +1. Which is what Tashana got and Awa got. Excellent. Okay, so I'm going to just remind you that there is still, for, if you haven't done it yet, there is the practice final exam, which is the last test that you are going to be taking for this term. It's on Blackboard. You get 2 chances to take it, and I will take the higher grade as your grade for that test. It is not optional. It must be done. Your final is a week from today, as I have written on the board here. It will be available starting at 9:30 a.m. That is the optimum time to take it. Start at 9:30. Once you start, of course, you have 2 hours to complete it. You will be finished by 11:30, but I will leave it open until 2:30. You must have it completed by 2:30. If this time does not work for you, if you have a problem with it, then you have to let me know so that I can arrange a different time, but you should be available because that's the time of our class. It's a regular class time. If you have any questions of any topics you'd like me to do, first of all, don't forget that there is sessions today, SI sessions at 12 o'clock, right after this class. If you have any questions about any topics, if you also want to if you want me to review any topics, I will be going over basically topics that we did from the beginning of the term, any things that I think might be of interest to you to do. That's going to be Thursday's lesson. Have a good day, and don't forget, this is it. If you have, I will be going through your looking at all your tests and making sure that anything that you have, and I'll let you know if you're missing homeworks. There is a little bit of leeway with the homeworks. You can, I have to look at this and I'll let you know if you, how many homeworks you must complete to get complete 10 points for the homework. Remember that 40% of your grade is from classroom. So homework is 10 points, and the tests, the other 5 tests are the other 30%. So you have to have all that work done. Okay, I will see you on Thursday. Have a good day.